next speaker. So let me do this right, because Andrew got a rough start. So let's go back to Andrew's bio one more time. Andrew Henry is the technical lead for the OpenMCT project at NASA's Ames Research Center and is based in San Francisco. Prior to working with NASA on mission control software, Andrew led software projects involving the Galileo satellite navigation system and climate data analysis systems in Europe. Andrew has also worked on a geostationary satellite management system with European industry and on an EVA planning research project for crewed missions to planetary bodies. So Ryan, I can see your screen perfectly well now, and if you have a camera and you would like to turn it on, we can see you as well. That's your call. Otherwise, you can proceed whenever you wish.
Great. Can you all hear me okay?
I can hear you. There is a little bit of background noise, but I can hear you.
Okay, my apologies about that. I've had to switch to an older computer, and the camera doesn't work on it. So unfortunately, you're just going to have to see OpenMCT rather than my face. Probably for the best. Thank you for your patience, Fabrizio. Thank you everybody else for your patience. My apologies. Thank you, Ryan, for stepping in. I was the victim of an overzealous institutional IT policy. These things happen. I'm up and running on another computer. This is a demonstration really of the power of open source software, because I've switched over, as I said, to an old personal laptop, and I was able to pull down the code and get up and running again in just a matter of minutes. So
great.
Yeah.
All right. Let's take a look.
So let's do it. So Jay gave you an introduction, if you can cast your mind back to OpenMCT, and laid some of the groundwork and background, and drawing on the institutional knowledge and experience of NASA and how we used to fly missions, and use that to inform the development of OpenMCT. So thank you, Jay, for giving everybody that context. I'm going to dive into the nuts and bolts a little bit more here, and talk about some of the technical aspects of OpenMCT. I wanted to start, before I do get into the technical details, with just sort of a quick demo, so that we all understand sort of what it is that we're talking about with OpenMCT here. So I'm going to open up a Hello World application that uses OpenMCT. So you can actually go to GitHub, and you can pull down the OpenMCT Hello World repository, and you can run this. I've built some displays for the purposes of this demo, so that I can show some of the capabilities of OpenMCT. So diving right in, so OpenMCT is a mission operations tool. It's web-based, it's open source, as we said. It provides sort of mission situational to spacecraft operators, and what I mean by that is it provides visualization of sort of real-time and historical telemetry. So here we can see new data coming in, and these plots are all sort of ticking along as time sort of marches forward. OpenMCT will sort of go off and sort of backfill historical data as well. So, as I navigate away and come back, I'm back to where I was, because OpenMCT is not just sort of capturing real-time data, it's also it's requesting archived historical data from the back end as well. So we can see real-time and historical telemetry displayed in plots. Down here in the bottom right, we have a plot with some limit lines as well. So OpenMCT will alert the user on the sort of violation of limits. So in this case, we have this display includes some instantaneous values. So these are just the latest values of these different telemetry points. And I'm going to use the term telemetry point quite a bit along the way. Telemetry points in OpenMCT parlance are anything that produces telemetry on the rover, on a spacecraft that OpenMCT knows about. Sometimes they're called parameters, sometimes they're called channels, These are telemetry producing things like sensors. So we have 4 different telemetry points here. 2 of them are in violation of an alarm. The first one is of a limit rather. The first one is showing an orange limit violation. The bottom one is showing a red limit violation. Our plots will also show where these limits lie. So you can see on this bottom plot here, we have kind of the orange or yellow limit and the red limit at the top there. So OpenMCT can show plots, it can show kind of real-time values, you can draw diagrams and include images and these kinds of things. It's sometimes useful to call out the physical location on a spacecraft where telemetry is coming from. That can sometimes be useful for isolating faults and understanding what might be going on if a bunch of anomalies are co-located in the same sort of physical space. We have plots in different time, clocks rather, in different time zones. We have some summary, what we call condition widgets rather, which are sort of indicators, they're status indicators, which can be used to summarize the state of some subsystem. So you can define rules that will, users can define rules that will determine the styling of these indicators. We can zoom in on plots and we can pan around and all those kinds of things, and we can sort of explore data visually. Just ticking through some of these other displays, OpenMCT can display images, as you see here. If the data is available, it will also show some additional contextual information if the data is available with the image. So, for example, this compass rose here is showing the direction that the image was taken in, which direction the camera was pointing, where the sun was, how the rover was oriented in this case. We have some indications of freshness in terms of how recently the picture was taken, and freshness in terms of how the spacecraft orientation or the camera orientation might have changed since the image was taken. The other thing to mention with these images is that, like our plots, you can kind of go back in time and you can see historical images as well for the duration of the time window that you're looking at. So right at the moment, I'm just looking at 1 minute worth of data. So you can see this time conductor element down at the bottom of the screen here. And I'll talk about that a little bit more in a moment. So let's see, we can also plot data. If we have a mixture of different sort of telemetry points that are maybe, these guys here are all producing sort of scalar values like numbers, but then we also have data coming in that's more kind of discrete, like images. These can all be plotted on a shared axis. So we call this the timeline view. So you can see, and everything's ticking along because we're in real-time mode, which means that we're seeing data as it comes in, and we're looking at a sliding time window. At the moment, it's configured to 1 minute. OpenMCT also allows you to integrate sort of activity plans as well. Another feature I wanted to point out is OpenMCT integrates with a tool called MMJS, or we are in the process rather of integrating with a tool called MMJS, which is a tool out of JPL, which is a multi-mission geographical information system. So it's sort of a mapping tool that gives you a top-down view as well as a 3D view of telemetry. So I can pull all of these things together into these displays. It's all within OpenMCT. Going back to Jay's remarks earlier, I don't have to switch between different applications to do this. It's all in one place. So yeah, there's cognitive load involved in context switching between applications. So if you have everything in one place, not only does it allow you to synchronize your data between the different views, but it reduces the cognitive overhead involved in having to sort of switch between different applications. So let's see. So these can all be combined in one place. The time window that I'm looking at can be controlled using this element at the bottom that we call the time conductor. So if I change that from 1 minute to 2 minutes, OpenMCT has gone off and it's gone and fetched more data from the back end, and it's still subscribing to new data and showing that as it comes in. I can pause what I'm looking at if I see something interesting, and now I'm in fixed time mode, so things are no longer kind of moving along. I can then move about in time. I can kind of pan things backwards, and you'll notice all of the elements on the screen are sort of updating at the same time, and they're showing a snapshot of how things looked at that moment in time. And I can go back to any period in the past that I have data for. So this enables multiple different sort of use cases for OpenMCT. So it can be used for real-time situational awareness, but it can also be used for anomaly analysis. So something happened in the past and you want to go back in time and see what the telemetry looks like coming from different parts of the spacecraft at the same moment in time when that anomaly happened. OpenMCT enables those sorts of use cases. So I wanted to talk about how the user goes about building sort of one of these display layouts that I've shown here. So before I do that, I just want to talk briefly about the concept of objects. So Jay mentioned these in his earlier presentation. Objects are sort of how OpenMCT represents things that it knows about, and these can be things like telemetry. So in this case, I have some mock telemetry. All this data is just coming out of switch back into real-time mode because it's a little more interesting. This is mock telemetry that's being generated in the browser right now, just for the purposes of this demo. But telemetry points are objects, but user-created things are objects as well. So I can create a plot, or I can create a display, much like the one that we were looking at a moment ago. And OpenMCT will represent that and save it as an object. And all of the objects that are available to users are represented in the tree on the left here. So let me go ahead and create a display real quick. Now I am going to, again, looking at the telemetry in the tree here. I'm just going to kind of grab some of these and copy and just drag and drop them into the display layout. And it's just a matter of drag and dropping. I can sort of reposition them once they're in there. The default presentation for telemetry is in OpenMCT, if you drop it into a display, is to give you sort of the latest values. Let's drop this in here as well. I can, if I want to, switch these over to, I can display these as plots if I want to, so I can combine them like that, and then that's going to kind of show them all in a plot. In this case, all of these values are, they're all sharing. I've chosen an overlay plot, so what that means is that they're sharing a common time axis, but they're also sharing a y-axis. And because these values are sort of quite far apart, they sort of just look like straight lines right now. So I could switch that over to a stacked plot, and then they all get their own axes. And you can see sort of the data a little more clearly now. I could view these as a table. So this will just give me kind of the raw numbers. And again, you can see that I've chosen a number of telemetry points that are all in limits violations at the moment. So it's all looking pretty red and yellow. So yeah, OpenMCT allows you to pivot between different sort of representations of your data. So the other thing that I can do here, so let's switch this back to a plot little more interesting to look at. I can go back and I can combine, you know, I can drag a clock in here. So let's go ahead and do that. I had some images in my other display, so let's drag some of them in. And yeah, it's as simple as sort of dragging and dropping things from a tree and then moving them about and positioning them and so on. So I can go ahead and save that now. I'm going to save and finish editing. That's going to persist this object, so I can come back to that even if I reload the browser. You know, it's still going to be there. Hello world. When I come back to it, by default, OpenMCT will use what's called browser local storage. So that exists only for me right now, but OpenMCT can be configured to also work, to persist your objects to a server. So we support CouchDB for doing that. So in that case, you know, I would be able to then share this URL with another user, or they could just log into OpenMCT and they will see it in the tree immediately after it's created as well. Okay, so I have talked a little bit about some of the capabilities that OpenMCT has out of the box, but what if it doesn't do what I needed to do? What if I would like to extend it with new capabilities or integrate it with my own telemetry source if it's one that there isn't an existing plugin for? How does that work? So to talk about that, I wanted to dig into some of the technical details a little bit here. And I'll keeping an eye on the time. So first of all, I just wanted to place OpenMCT within a ground data system. So we have OpenMCT is a browser application. So it's a bunch of JavaScript and HTML and CSS essentially. So it can be served
Andrew, you can go on for a half an hour, so no problem with time. Okay.
Okay. Thank you.
Yeah.
Thank you.
Sure.
OpenMCT is JavaScript and HTML and CSS. So it can be served up by any web server, Apache, Nginx, Express.js, etc. I talked about shared persistent stores. So we support CouchDB out of the box. We have an API that allows you to extend it, so you could support other persistent stores as well, other document stores, things like you know, Elasticsearch and those sorts of things. OpenMCT, being a browser application, it receives telemetry from some telemetry processor. So it's not a telemetry processor itself. So OpenMCT is adaptable to the different needs of different missions, because what we found is, as Jane mentioned, every mission is different. They have different needs. Missions use different telemetry processors. Someone might be using Cosmos, some might be using ITOS, some might be using YAMPs, etc., etc. So we, on the OpenMCT project, have said, you know, use whatever telemetry process you're familiar with, you're comfortable with. There are a number of plugins available to talk to some of the commonly used telemetry processors or telemetry backends. So there are plugins for YAMPs, AIT. AIT is a project out of JPL, as is AMPCS, ITOS, and some others. OpenMCT is agnostic about where the telemetry is coming from. And it sort of achieves this agnosticism via an adapter layer, which we're going to dig into a little more once we get into sort of the live kind of coding exercise and what that means. But suffice to say for now, OpenMCT will talk to whatever telemetry backend you're using. It will request historical telemetry from it and subscribe to new data, sort of as it comes in. I talked about some of the telemetry backends that there are plugins available for OpenMCT for, so I won't dwell on that too much. I did want to talk just briefly about extending OpenMCT. So let's say I have a CubeSat mission. I want to use OpenMCT. How do I do that? So OpenMCT, the source code is available from GitHub, and I'll provide the URL for that in a moment. We also publish to NPM, the Node Package Manager repository. So we publish our build artifacts there. So that's the way that we sort of recommend using OpenMCT, is using it as a dependency for your own project. So you would define OpenMCT as a dependency, and then in your project, install the OpenMCT plugins that are relevant to your project. So in this example here, I want to use CouchDB to store my user-created objects, so my displays that I build, my plots, my tables, my condition widgets, these kinds of things. So I'm going to install the CouchDB plugin, which is provided by the OpenMCT project. That CouchDB plugin is going to go off, and it knows how to talk to CouchDB. Let's say I want to use YANS as my telemetry backend. There is a YANS plugin available that will allow OpenMCT to talk to YANS, so I can just go ahead and install that. That's provided. That plugin knows how to talk to YANS and to feed telemetry into OpenMCT. But let's say for my particular project, I want to use my ground data system is going to be producing lots of status messages using a real-time messaging system. So it might be, Kafka or something like that. So in that case, I could write my own Kafka plugin because one doesn't exist right now. That plugin will use the OpenMCT API, the telemetry API, to register a new Kafka telemetry provider. So, in cases where OpenMCT doesn't have a plugin for what you need to do, it has API that allows you to extend it and define your own plugins. And then that Kafka plugin knows how to talk to Kafka and feed those real-time messages back into OpenMCT, so that you can then build them into your display layouts, view them in tables and alphanumeric telemetry displays and those sorts of things. Let's say for my project, I want to show sort of a 3D representation of my spacecraft as well. Then I can use the OpenMCT API, specifically the View API, to extend and OpenMCT and define a new 3D spacecraft plugin for it, and a new 3D spacecraft view. So that I would register a new spacecraft view provider, which would include Unity web player if that was the rendering engine that I wanted to use, or I could use 3, or I could use something that I built from scratch in WebGL. But the idea is that OpenMCT, we want to provide plugins where possible, or we hope that the community, going back to what Jay said about building a community of open source plugins, our hope is that missions will never have to write a line of code, but we don't live in an ideal world. So in cases where a plugin isn't available, we provide an API for extending it so that it can do those other things, and we encourage you to release your new plugins as open source projects as well. So the OpenMCT API allows you to define new sort of views and visualizations of your telemetry, new telemetry adapters to talk to different backend systems, telemetry backends, new types of objects, actions, which I didn't really kind of talk about in the demo, but if I right-click on some of the objects in the tree here, I see a context menu with a number of actions. These are what actions are. These are sort of verbs or things that you can do to objects. So the API can be used to define new actions. User notifications, so these can be used to draw people's users' attention to something that's happening in the system. Indicators. Indicators are things that appear in the sort of the tray at the top of the screen here, and they can be used for monitoring the status of, for example, I might build an indicator that tells me the status of the ground station, for example. Is it connected? Is it downlinking from the spacecraft at the moment? Those kinds of things. Okay, OpenMCT, you can download the source code from GitHub. That's the URL. And while I'll just leave that up for a moment while I sort of set up the next stage of this presentation, which is a live coding exercise where what I'd like to try and do is just sort of a fairly simple exercise to integrate OpenMCT with a new source of telemetry. So something that it doesn't do right now. So I've shown a lot of sort of mock telemetry, which, as I say, we're just generating in the browser. They're just sort of fake, sort of quasi-random values. So what I'd like to do now is actually grab some real data. So let's close this down for a moment. What I thought might be a good source of data is the Curiosity mission. So if you go to this webpage, mars.nasa.gov/nsl/weather, you can see data for the last 7 days from the REMS instrument on the Curiosity rover. So this is basically a weather station. So this is giving me high and low values for temperature on these different days. So we have 7 values there. You know, we could plot that. It wouldn't be, you know, a super interesting plot. But if I look sort of behind the scenes here, I can see something kind of interesting, which is that when the site is fetching that data, it's actually fetching a lot more than just 7 days worth of data. If I take a look at the data that comes back, and I'm just in the dev tools in Chrome, I can see that in fact there are thousands of sols worth of data coming back, and sols are sort of Martian days. And if I drill down into that data, it's actually pretty interesting. I'm getting a bunch of interesting stuff. I can see pressure. I can see the temperature, which is being shown on the website. So there's some interesting stuff here that we could potentially plot: wind speed, et cetera. So let's do that. Let's go ahead and try and plot some of this data. So for that, I'm going to open up my IDE. I'm going to open the Hello World application again, which here. Okay, it's saying Hello World. Okay, now we're in OpenMCT again. Let's see, just a moment. This computer is a little old and sleepy, so things are kind of not super fast right now. Okay, here we go. Okay, so the application, so all this application is doing right now is loading OpenMCT. So obviously you can see OpenMCT has loaded here, and loading the user with Hello World. This is the basic form. What we're seeing here in this code is the basic form, and I apologize. This is JavaScript. For those of you that aren't familiar with it, I apologize. I'll try to sort of explain as much of this as I can as I'm going along. If you're familiar with C or Java or languages like that, it's probably all going to make a reasonable amount of sense to you. Anyway, so this is the basic structure of an OpenMCT plugin. And an OpenMCT plugin at its most simplest is simply an install function, and that's it. And this function will have OpenMCT passed into it when it is installed by OpenMCT. So right now, all this is doing is alerting the user and saying, hello world, when this plugin gets installed. So let's take a quick look at where that plugin is installed. So index.html. So again, this is just an HTML application. It includes OpenMCT, first of all. So OpenMCT is getting included at the top here in the script tag. And then it's also including my Hello World plugin as well. And then let's talk about what's all these other lines of code in a minute. But let's for now just jump ahead to this line here, which is installing my Hello World plugin. So that's simply installing the plugin that I have defined here that says Hello World. So with that plugin installed, when I load my application, I see Hello World. Going back into index.html for a moment, it's also installing a bunch of other plugins. And that's because OpenMCT, as I said, is designed from the outset to be very customizable and adaptable to different missions. So as such, everything is a plugin in OpenMCT. All of its capabilities are plugins. So you can run it in a pretty minimal fashion if you want to. I've enabled a bunch of plugins so that I have something to show you for this demo. But these plugins are all sort of documented on our website and so on. So what this is doing is just setting up and installing some plugins so that we have something to look at for the purpose of this demo. We can ignore the details today of exactly what's going on here and focus on the Hello World plugin, which is what we're building. Okay, so the first thing to do here, the first thing that I want to do is actually I'm going to go ahead and install another plugin, and that plugin is going to actually install a basic rudimentary telemetry dictionary for me. So in order to represent my, I'm going to choose the minimum temperature value. So let's just go back to this data again. I want to plot the minimum temperature. So we need a very rudimentary telemetry dictionary that just has the minimum temperature in it. So for the purpose of this demo, I'm going to skip a few steps. I've pre-built a dictionary, and I'm just going to go ahead and install that. The dictionary is right here, called Mars Weather. Let's take a very quick look at it before I install it. The dictionary defines an entry for the temperature. The type of it is a Mars Weather telemetry objects type. And then there's some metadata about the telemetry. And this telemetry metadata tells OpenMCT how to interpret the data. So in order to plot it, I'm going to need two things. I'm going to need a timestamp so that I can associate it with a point on the x-axis, which is time in our plots. And I'm going to need some value of some scalar value to plot for the y-axis. So in this case, it's going to be minimum temperature. So I'm providing OpenMCT with some information about it. So I'm saying the format is UTC. That has a specific meaning in OpenMCT, but it's basically going to allow me to interpret a date in that sort of format. And then my minimum temperature is just a number. So if we look at the minimum temperature there, it's just a number. I said number because in the world of JavaScript, it doesn't differentiate between floats and integers and those kinds of things. Everything's just a number. So I'm saying minimum temperature is a number. So let's go ahead and install. Let's go ahead and install that telemetry dictionary. I'm going to use something called, so OpenMCT exposes all of its plugins via OpenMCT.plugins. I'm going to call it. So I'm going to use the static root plugin to expose it, and I'll explain in a minute what that means. And it is, the name of the file is mars-weather.json. Okay, let's go back to our application. Okay, so now at the root level, we have a new folder called Mars Weather, and underneath that we have one entry, minimum temperature. So I've used something called the static root plugin to add my dictionary to the top of the tree there. The reason that it's not called the dictionary plugin is because you can use it to basically add anything that you like at the top, at the root node of the tree, based on a kind of static JSON file. And it's not necessarily just going to be a telemetry dictionary. You might, for example, want to define some displays that should never change during the course of the mission, or they should be version controlled or something like that, because you don't want things to suddenly be in different places in a display while the mission is flying. So that's why I'm using the static root plugin to expose my telemetry dictionary in the tree. So let's go back into the plugin itself. You'll notice a couple of things here. If I click on it, I don't see any telemetry yet. I see a plot moving along, but I'm not seeing any data in it because I haven't told OpenMCT how to fetch the data yet. The other thing you'll notice is there's a question mark next to the minimum temperature here. That is because in my dictionary, I told OpenMCT that this is a Mars weather telemetry type object, but OpenMCT doesn't know what that is. So the first thing that I'm going to do is actually register a new object type just very quickly. And I do that by calling OpenMCT.types.add type. Oops. Forgive me, I've had to switch to a Windows laptop, and the keyboard shortcuts and so on are all different.
No problem.
Okay, so I'm going to, so this is the key for my new type, which corresponds to what we have in the telemetry dictionary here. And then I'm going to tell OpenMCT a little bit about my new type. So I'm going to call it Mars telemetry. I'm going to call it specifically Mars weather telemetry because that's what it is. Okay, so I'm going to hit save. My application is going to reload. So the question marks disappeared, but now we have nothing there. The reason for that is because I haven't specified an icon. So just to make it sort of look a bit prettier, I'm going to give it an icon. This is, you don't have to do this. This is completely optional. I'm going to use one of our built-in ones. Because all you're defining is a CSS class, you can define your own icons as well. Okay, now I have a little icon for my new minimum temperature telemetry point. I'm still not seeing any data yet though, and that's because I haven't yet told OpenMCT how to go and fetch the data. I've told it about the data to expect. We've done that by defining a new telemetry type, and we've done it by defining some telemetry metadata in our dictionary. So let's go ahead and actually fetch some data. So to do this, somewhat predictably, I use the telemetry API, and I'm going to add a new telemetry provider. Telemetry providers, the basic interface for them is pretty straightforward. There are two functions that we're going to use today. The first one, so because we're not getting real-time telemetry from Mars, we're just going to provide historical telemetry in this case. We're not going to be able to subscribe to real-time data because we just don't have it. It just doesn't, it's not available. So I am going to, the first function I'm going to implement here in the telemetry provider interface is supports request. So this returns a Boolean and tells OpenMCT whether this telemetry provider can provide telemetry for a given object. So in this case, I'm going to inspect the object and say, if it is a Mars weather telemetry object type, then yes, I can provide telemetry for it. So, okay. So now things are changing on the screen. I've got a spinner here now. It's trying to fetch data because we've said that we support historical requests, but we're not actually returning any data yet. So to do that, we just define a request function. I'm gonna make this an async function because the process of going off to a server and fetching some data is asynchronous. So I need to tell the JavaScript runtime that this is an asynchronous process. Again, an object is going to be passed in, the telemetry object that has matched this first function. So everything is very object-centric in OpenMCT. Then I'm actually just going to go and fetch the data. So I am going to use the built-in JavaScript fetch API to do that. I'm going to go back to this page. Well, actually, I'm going to go back to the dev tools that shows me sort of behind the curtain what's going on this page. And I'm going to copy this URL, and I'm going to use that. Looks like I didn't copy all of it. Hopefully that works. So what that's going to give me at this point is basically it's going to give me something that looks a bit like this. So it's going to give me a string. So that a raw string of sort of serialized JavaScript object called JSON. So the first thing that I want to do is actually sort of deserialize that into JavaScript objects, so that instead of a string, I have a collection of sort of JavaScript objects. So let's do that first. Okay, and now I have something that looks more like this. So we have a bunch of JavaScript objects. Now, the final step here, and we're nearly done, is to transform the data that we receive so that it conforms to the dictionary that we defined here. So the way that I'm going to do that, so we look at the structure of the data. What we get back, it has this attribute sols, which has the data for each Martian sol on it, and that's an array. So we're going to take that array, we're going to call the JavaScript array map function on it, and this is a function that just transforms data from one form to another. So for each element in this array, it's going to perform some transformation, which I'm going to define on it. So for each, I'm going to say for each sol, return a new object, which is sort of much simpler and is just the data that we're interested in, which in this case, apologies, I keep hitting the wrong keyboard shortcuts. It's muscle memory kicking in from the Mac. So we've decided it's going to have two things. It's going to have a timestamp, which we've called UTC. So I'm going to get from sol. In this case, it's called terrestrial date. So let's copy that. Terrestrial date. And I am going to get the minimum temperature as well. So again, sort of going back to our telemetry dictionary, we've decided to find something called min temp. So let's use that. Use the minimum temperature, and we're going to go sol dot min temp, because that is also what it's called in the data that we get back. There's one other step that I'm going to do here, which is just transform this date into a native JavaScript date, essentially, rather than a string. The way that I'm going to do that is using date.parse. Okay, I'm going to hit save at this point. And then if we go back to our back to OpenMCT, where we're not seeing any data. We're seeing a plot that's moving along. The reason we're not seeing data, hopefully, is because we're only looking at the last 1 minute worth of data, and we're not, we don't have data in the last minute from Mars. So let's switch to a fixed timespan node. Let's go all the way back to 2012, when this mission landed. And if I do that, then instantaneously, I can see this, I can see data, and I can see a sinusoidal sort of pattern, which is a consequence of, seasonal changes in the minimum temperature at the landing site of the Curiosity rover. And I can kind of zoom in there, and I can explore the daily fluctuations in temperature, in minimum temperature. So, okay, so we're just about out of time. So I'm going to pause it there. I could then, now that I've integrated this, let's just quickly sum up what we've done here. We've taken OpenMCT and with a few sort of lines of code here, we've integrated it with a completely different disparate data source, which it wasn't connected to previously. I can now use this alongside the telemetry that I was looking at previously. I can build it into the display layouts and so on and so forth. So yeah, I'm going to pause there. I hope you all enjoyed the presentation. Again, my apologies for the technical problems at the start there.
Well, I need to say that, Andrew, this was a remarkable comeback from a difficult start. So thank you. And it is true that the fact that you were able to install everything in a few minutes is a testament to the flexibility of the software as well. So thank you very much. I mean, this is a lesson that we will ponder about for some time, because it's easy to you, but this was obviously a new world for many of the students here. So I really appreciate it. And I remain very enthusiastic about OpenMCT and very interested in learning about it. And that is not to say, I guess that you and Jay were not around, but we were commenting about to what extent Cosmos, OpenMCT, and other similar code is redundant, to what extent it's complementary. And I can't say that I understand it, because that's I hear the word telemetry all day. So, but obviously it is clear by looking at what you do that these solutions are not redundant. I mean, in the sense that there are different ways to approach these problems. So if you would like to comment, or Jay, about the relationship between this product and other telemetry products, although this is, I don't know if you would characterize this as a telemetry only product, but the place of OpenMCT in the broader landscape. That's what I guess the question would be.
Yeah, I mean, I can take a first pass at that, Jay, and if you have any comments, you can jump in as well. I certainly, I think it's complementary, where to some extent, there's certainly some overlap in the sort of the Venn diagrams of tools like OpenMCT and Cosmos and YAMPs and these kinds of things. But we're very much more focused on the front end and presenting data to users. We're not attempting to do any sort of telemetry decommutation or anything like that. We're trying to specialize on the problem of situational awareness, and let others who already have great products that are doing the telemetry processing, let them focus on that and build on the work that they're doing. So at least that's sort of the way that I see it. And Jay may have some thoughts.
Yeah, I mean, I agree with everything Andrew said. We'll reiterate, right? There's so many products out there already. What we felt wasn't there was a state-of-the-art user interface that could integrate everything right into one place. So we've really focused on what we felt existing products did not do, which was really very much at the user end of things, right? Integration, data display, composition.
That is great. I'm, as I say, I'm impressed, and I look forward to, from the pedagogical perspective, I look forward to understanding how we can take all these products that we have seen and give them a place inside of my educational program. That's what I really am interested in understanding. So, so thanks very much to the NASA Ames group, and unless there are other questions from the from the student body or anyone else. Okay, so we'll stop here, and so just a second of update so that we clarify what happened